Hey everyone, today we're going to talk about something that's, well, it's a huge deal for our food, but you probably never even think about it. We're talking about water quality for farming. It's kind of like the secret ingredient that can make or break a whole harvest.
All right, so take a look at this. If you were a farmer, what would you think? Looks pretty good, right? It's clear, it's flowing. I mean, what more could you want for your crops? Well, here's the twist, and this is what we're going to get into today. When it comes to irrigation, looks can be super deceiving.
See, the most important thing to get is that it's not just about how much water your crops get. It's really all about what's in that water. The quality, you know? The invisible stuff, the chemistry dissolved in it, that can have a massive impact on the soil and, of course, on the food that winds up on our plates.
Okay, let's jump right in with the first big problem here, salinity. And I love this description, when water makes plants thirsty. How is that even possible, right? It sounds like a total paradox, but it's exactly what happens. Think about it like this. If you're stranded in the middle of the ocean, you're surrounded by water, but you can't drink a drop of it. Well, that's pretty much the same pickle a plant finds itself in when the soil is too salty. So how do we even measure this? Well, scientists use something called electrical conductivity, or ECW for short. Basically, the higher the ECW, the more salt is packed into that water. And those salts, they create what's called osmotic pressure. The best way to picture it is like a giant game of tug-of-war. The plant's roots are on one side, trying to pull water in, and the salt in the soil is on the other side, pulling water out. If that ECW gets too high, the salt team wins the game, plain and simple. The plant literally can't drink, even if it's sitting in wet soil.
And check this out. This shows you what that actually means for the food we eat. Let's take peaches, for example. With a low salinity of 1.1, things are great. You get 100% of your crop. But just look at how fast that yield drops as the salt level creeps up. By the time you hit 2.7, your yield is cut in half. Can you imagine? Half your peaches gone. That's a huge, huge loss for a farmer. And it's all because of something you can't even see in the water.
But, you know, nature's pretty smart. It has a built-in workaround. Not all plants are created equal when it comes to salt. So on one side, you've got a super tough crop, like barley. It can handle a ton of salt. But then on the other side, you have something really delicate, like a strawberry. It just can't take it. And the difference between the most tolerant and least tolerant crops is, it's just massive. We're talking like an 8 to 10 times difference. This is awesome for farmers because it gives them a really powerful tool. If your water's a bit salty, maybe you don't grow strawberries. Maybe you grow barley instead.
Okay, so that's the whole saltiness problem in a nutshell. But that's not the only thing we have to worry about. Let's move on to our second big issue. Sometimes it's not just the total amount of salt, but specific little troublemakers in the water that act like poison to the plants. And even weirder, sometimes the water can actually cause a physical problem, literally sealing the soil shut so water can't get in.
The main culprits we're talking about here are elements like sodium and boron. Now, plants do need a tiny bit of this stuff to be healthy, but when you get too much of it in the water, it's basically like a slow-acting poison. The roots soak it up, it travels all the way up the plant, and it just collects in the leaves. That's what causes that classic burnt, crispy look you sometimes see on the edges of leaves.
Now to figure out just how risky the sodium is, we have a special measurement for that. It's called the sodium absorption ratio, or just SAR. And the really important word there is ratio. It's not just about how much sodium there is. It's about how the sodium stacks up against two good guys, calcium and magnesium. If that SAR number is high, it's a huge red flag. It's a warning that your water might be about to wreck your soil.
And this shows you exactly how that disaster unfolds. It's a chemical problem that creates a physical nightmare. So here's what happens. Step 1, you apply that high sodium water. Step 2, the sodium bullies its way in and kicks the calcium off the little soil particles. Now, calcium was basically acting like the glue holding everything together. So without it, the soil structure just falls apart. The particles scatter. And then, those tiny particles clog up all the little air pockets in the soil, forming this hard, concrete-like crust on the surface. And just like that, your soil is practically waterproof. The water can't get in, it just sits there in a puddle.
Okay, I know this all sounds pretty dire, right? But don't worry, this is where things get really cool. This is where the amazing ingenuity of farmers comes into play. They have developed an entire toolkit of really smart strategies to handle these kinds of water problems and still grow fantastic crops.
So what's in this toolkit? Well, you can kind of break it down into four main approaches.
First, there's something called leaching. That's basically just flushing the soil with extra water to push the salts down deep, way below where the roots can reach. Second, you can add amendments, things like gypsum, to fix the soil's chemistry. Third, as we already talked about, you can pick your battles and just choose to plant crops that are naturally tougher against salt. And fourth, and this one's a big one, you can totally change how you water in the first place.
Let's look at a perfect example of one of those amendments: gypsum. So remember that problem where high sodium and low calcium made the soil clog up? Well, the solution is pretty straightforward. You just add more calcium. Gypsum is basically calcium sulfate, so by mixing it into the water, farmers can fix that chemical imbalance. The soil particles start clumping together again, the pores open back up, and voila, the water can soak in again. It's a really neat, effective chemical fix for a physical problem.
And that brings us to what might be one of the most powerful tools of all. And what's interesting here is that it has nothing to do with changing the water itself. It's all about changing the technology you use to deliver it. Okay, just look at these numbers for bell peppers. Let's say the old school way, furrow irrigation is our starting point. Now, just by switching to sprinklers, you get a 50% bigger harvest with the exact same water. That's already amazing. But the real game changer? Drip irrigation. Look at that bar, a 75% increase. That is incredible. Drip systems are so smart. They put the water right at the base of the plant, drop by drop. So you lose way less to evaporation, and you don't get that salt buildup on the surface. It's just a crazy efficient way to use every single drop.
All right, so we've looked at the nitty-gritty of the problems and the solutions on the farm. But now, let's kind of zoom out for a second and think about the big picture. Why does all of this matter? Why is getting good at farming with less than perfect water so important for every single one of us?
I just have to share this number because it's just mind-blowing. There's an 8 to 10 times difference in salt tolerance that already exists naturally among our crops. We're not talking about fancy, futuristic genetic engineering here. This is just the amazing biodiversity that's already out there. It's like nature handed us this incredible toolkit that gives us a huge head start for adapting to a future where clean, fresh water is getting harder and harder to come by. And this right here, this is where you can really see the future starting to happen. All around the world, in all sorts of places, we're seeing this amazing idea take hold. Cities are taking their wastewater, treating it, and making it safe to use for farming. Think about that. It creates this beautiful, sustainable loop. You're turning something that used to be waste into a precious resource that helps grow the food we all need. So I want to leave you with this question to chew on. We've talked about all these clever solutions that farmers are using right now. But as our world keeps changing, as fresh water becomes even more precious, what's next? What's the next big idea? What new technologies, or new kinds of crops, or completely new ways of thinking are we going to need to keep feeding everyone on this planet with the water we've got? That's the challenge for all of us. Thanks for joining me.